All right, so today we're going to start on page 7 of our new workbook. So the workbook that was just handed out to you or that was on your desk, we're starting on page 7. So go ahead and find that page and then we'll get started. Page 7. Okay, so what we're going to talk about this unit has a lot to do with exponents. We've talked a little bit about exponents when we did our order of operations. But remember, an exponent just tells you how many times you're multiplying a number together. So for instance, 1 squared means 1 times 1. And then 1 times 1 obviously gives us 1. So 2 squared, same thing. That means I'm taking 2 and I'm multiplying it together 2 times. So 2 times 2 gives me 4. Yeah, so the big number, this is what we call our base. That number is what we're going to multiply together. And then the exponent tells us how many times. So 3 squared means we're going to take 3 and multiply it together twice. So 3 squared means 3 times 3, which would give me 9. So there's 2 ways that we can do this on our calculator. If we want 4 squared, meaning 4 times 4, you could obviously just type in 4 times 4 and get your answer. You can also, if you want to do the exponent, if you hit 4, and then you're going to hit this little caret button, we call it a caret, this little arrow up button, and that's telling us 4 to the, and we put second power, and that'll give us the same answer as just multiplying it ourselves. So if we keep going, 5 squared, 5, we use that up arrow to the second power. 5 times 5 gives us 25. 6 squared means 6 times 6, 36. 7 squared, 7 times 7 is 49. 8 squared, 64. 9 squared, 81. And if you're feeling good about this, you could pause the video and finish out this row yourself. And then I'll put up the answers. 11 squared gives me 121, right? 11 times 11. We can do 11 to the second power, gives us 121. 12 squared, 12 to the second power, gives us 144. 13 squared, 13, again, that up arrow is what we use to get our squared. Gives us 169. 14 squared is 196. 15 squared is 225. 20 squared is 400, and 25 squared is 625. It's very important that you know these fairly quickly. We use them a lot, so it's important that you're able to do these or memorize these or know these off the top of your head because we will see them a lot this unit. So then if we move over to our other exponent column here, this is just cubed. So that means I'm going to take the number 1 and I'm going to multiply it together 3 times. So 1 times 1 times 1 still just gives me 1. 2, I'm multiplying 2 times 2 times 2. So you can multiply it out yourself. 2 times 2 gives you 4 times another 2. 4 times 2 would give me 8. You can do it on your calculator. 2 times 2 times 2. Or you could use the exponent button, 2, that up arrow right there, and then pick the number 3 to the third power. You get the same answer either way. So 3 squared means I'm multiplying 3 together 3 times. That would give me 27. 4 to the third power, or 4 cubed, would give me 64. 5 cubed, 5 to the third, is 125. And then 6 to the third is 216. Our cubes we don't need to know as much. The squares, it's really important that we know and are able to solve. All right, so now I'm going to have you turn your paper over to page 9. We're going to take some notes here. So go ahead and find page 9 so we can do our notes on exponent rules. All right, so on page 9, with our exponents, there are a couple of rules that we're going to follow. So we're going to look at these rules. The first rule is our product rule. There's 5 rules that we're going to look at, but today we're going to start with our product rule. So if we look at these terms here, we're going to kind of expand them to see what they look like, and then combine them all together. So 3a to the third, that 3 I'm just going to keep. There's not really anything we can do with the 3. A to the third means I'm multiplying a together 3 times. So I'm just going to write that out, the expanded version. Then b to the fourth means I'm going to write b out 4 times. And so I've expanded that term here so that I don't have any exponents. So I'm going to do the same thing now with this one. I'm going to bring that -7. And then my a's, I have 2 a's. That means I multiplied a together twice. And then I have 3 b's. So that means I multiplied b together 3 times. So to find our answer, we're going to combine the coefficients. Those are the numbers in the front. So 3 and -7. If I multiply 3 times -7, I end up with -21. And then I'm going to bring all of my a's together and all of my b's together. So for my a's, I'm multiplying 1, 2, 3, 4, 5 a's together. So it's going to give me a to the 5th. And then for b's, I have 1, 2, 3, 4, 5, 6, 7. So I have 7 b's total. So I counted how many a's I had. That told me my exponent. Then I counted how many b's I had, and that told me my other exponent. So we're going to do the same thing for our other example. So we're going to expand it all out. Then we'll count how many x's we have and count how many y's we have and combine them together. So I have 5 x's. 4, 5. Oops, that's a y. And then I have 2 y's. And then in my other term, I have 6 x's, 2, 3, 4, 5, and 7 y's. So I expanded these two terms out, right? X to the 5th means I multiplied x together 5 times. Y to the 2nd means I multiplied y together 2 times. So I expanded it all out, and now I'm going to put all the x's together and all the y's together. First, I'm going to multiply these coefficients. So 2 and 6, 2 times 6 would give me 12. Then I'm going to add all these x's. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's total. So that means I'm going to have x to the 11th. And then for y's, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 y's total. So that'll be y to the 9th as my final answer. So hopefully you noticed a pattern with our exponents. Right here I had a to the 3rd and a to the 2nd. And when I combined those, I got a to the 5th. Here I had b to the 4th and b to the 3rd, and when I combined those, they became b to the 7th. So what hopefully you noticed is that we added, when the bases were the same, when we had that same base, both a's or both b's, we added our exponent together. So when the bases are the same, we added the exponents together. I didn't do anything, right? I only combined my a's. I only counted out my a's to get a to the 5th and b to get b to the 7th. I can't combine a's and b's together to make one mega exponent. They each have their own exponent for each base. So that leads us to the product rule. Our product rule says when you're multiplying exponents, you'll keep the base and add the exponents together. So you're going to keep the base and add the exponents together. Okay, so a couple things to keep in mind, and if you want to write this at the top, the first thing I would do in this process is I would multiply those numbers in the front together. Multiply the coefficients. Those are those numbers in the front. Then I'm going to add the exponents together. So the big numbers in the front, we always multiply together, and then the rest of them, we add those exponents. The little numbers we're going to add together. So let's look at some examples. So we'll do these ones on this page together. Feel free at any time to pause the video if you need to catch up with the notes, and then you can move on with us once you're ready. But make sure you've got all this written down before you start the practice, so feel free to pause at any time. Okay, so if we look at number 1, I said the first thing we're going to do is we're going to multiply these coefficients together. Those first numbers in the front, we're going to multiply those together. So negative 5 times 4 is going to give me negative 20. So those I multiply. Now I add my exponents together. So these m's don't have exponents, but what they really have is an imaginary 1 as their exponent. So I have m1 and m1. So to combine my m's together, m1 times m1, I'm going to add my exponents. So 1 plus 1 gives me 2. So that gives me m to the second power. Then I'm going to do the same thing with my n's. I had n to the fourth and n to the third. So I'm going to add my exponents together, which gives me n to the 7th. And so that will be part of my answer. So my final answer is negative 20, m to the 2nd, n to the 7th. I multiplied the front numbers, but then I added my exponents for both my bases. All right, let's look at number 2. So again, first things first, multiply those big numbers in the front. So I'm going to multiply 7 times negative 8. So 7 times negative 8 would give me negative 56. So now I'm going to look at each base that's the same and combine those. So here I have an r to the 2nd and an r to the 7th. So when I combine those, I'm adding 2 plus 7, which gives me 9. And then I'm going to do the same thing with the s's. I have s to the 5th and s to the 3rd. So then when I add those together, 5 plus 3 would give me s to the 8th. And that would give me my final answer once I've combined all my r's together and my s's together. Good. So the last one we'll do together. We're going to multiply the numbers in the front together first. So 4 times 6. 4 times 6 is 24. So that's going to tell me my coefficient, the leading number, 24. Now I'm going to combine my x's and I'm going to combine my y's. I'm going to combine those like letters. So I can combine x together, right? X to the 9th times x. Remember, if it's just an x, it has an imaginary 1 there. So then when I add those exponents, 9 plus 1, it's going to give me x to the 10th as part of my answer. And then I'm going to do the same thing with my y's. I have y to the 4th and y to the 3rd. So when I add 4 plus 3, I end up with y to the 7th. And that will end up giving me my final answer when I combine them all together. Okay, so now we're going to practice our product rule. So go ahead and turn to page 15. We'll go over a couple together, and then I'm going to have you work on this page before we move on. So find me page 15. Page 15. So I want to just talk about a couple that are a little bit more complicated. Yeah, if we look at some over here, right, this one we have 3 things we're multiplying together. That's not going to change the process. That just means we have more things to multiply together. So let's look at 21. We're going to look at like 21 through 29. So starting with 21, again, always start by multiplying the coefficients together. So multiply 7 times -2 times 3. So 7 times -2 times 3. So if I do that, 7 times -2 times 3 gives me -42. So that's going to be my leading coefficient, that number we put in front. So now we're looking for like letters that we can combine. So I have A squared, and I have A here. So I have A squared, and A. Remember, if they don't have a exponent, the imaginary exponent is a 1. So now I'm going to add all of those up. 1 plus 2 plus 1. 1 plus 2 plus 1. So 1 plus 2 would give me 3, plus 1 more would give me 4. So this is going to be A to the 4th when I add those together. Then I'm going to look for B's. Here I have a B to the 3rd. Here I have a B, and here I have a B. So I have B to the 3rd, a B, and a B, which tells us I have a 1 here and a 1 here. So then when I add those together, 3 plus 1 plus 1 is going to give me 3 plus 1 is 4, plus 1 more would give me 5, would give me B to the 5th. You don't need to write out all these steps every time if you can just remember to add them together while they're in the problem. So for instance, if we look at 23, I'm going to multiply 8 times 9 times -6 together first. So 8 times 9 times -6. Oops, I messed up. Times -6. And that gives me -432. Now, I have 5 A's here. There aren't any A's here, so there's nothing to account for there. And 2 A's here. So 5 plus 2 would give me 7. And then for B, I don't have any B's here. I've got 1 here and 2 here. So that would give me 3 total. So we don't have to write all those steps out. If it helps you, that's a great idea. If it doesn't help you, don't worry about it. You can just add them together in the problem like we did. Okay, so these next couple are tricky, and it's only because, right, when we multiply, when we're adding those bases, when we do A and A and A, the base stayed A, and we just added the exponent together. So in a problem like this, I am not going to change the base. The base is going to stay 10, and I'm adding my exponent together. 2 plus 3 gives me 5. So even when it's a number, a letter or a number, the base stays the same, and we just add the exponents. So in this case, 5, 5, and 5, my base is going to stay 5, and then I'm going to add my exponents together. 3 plus 2 plus 4. 3 plus 2 is 5, plus 4 is 9, would give me 5 to the 9th. You're just adding them, only the exponents together. Okay, and then 29. This problem is just tricky because I can't add 2 plus r together. There's no such thing as a 2 and an r being added together to give me something. So it really just stays 2 plus r as the exponent, right? The base stays the same, and we're just adding those exponents together. Those are the really tricky ones at the bottom. I'm not so much worried about those as I am the rest of the ones at the top. So if you'll go ahead and look at the ones at the top, starting with number 1, and work your way through these. And then after a while, we're going to move on to our next rule. So pause the video, work on this page, and then when you're about done with it, you can start the next, or you can finish watching the video for our division rule. Okay, so I lied. Finish this page and then watch the next video that's on quotient rule.